So first of all, here we have object recognition, and then we are going to see our MobileNet SSD, because here we are going to use a deep learning model. Okay, so which is a pre-trained model, that is MobileNet SSD, which is used for object recognition, and we are going to deploy that pre-trained model MobileNet SSD in our Raspberry Pi to recognize the object which is present in front of the camera. And then of course finally we are going to have the discussion and then tech news. So the request for this course, so here we need a USB camera as well as the speaker. Okay, so while talking about the object recognition, so object recognition can be done in many ways. So before that, so object recognition in the sense in front of the camera or in an image, so what are the objects which is present in an image? So for example, it may be a car, it may be a cycle, or it may be a dog, or it may be anything. Okay, so from the digital image, it can be able to recognize where like what are the object which is present in there and where it is located. Okay, so not only detection, it is also a combination of detection and then tracking. Okay, so for example, so if I'm projecting this camera like this, so it will identify, this deep learning model will identify here I'm located in here. Okay, so even I'm moving like this, or left side or right side, so it will track me, right? So that kind of that concept is known as object detection and then tracking. Okay, so that object recognition can be achieved in many ways. So for example, you can use the machine learning, deep learning. So on the deep learning itself, like you can build object recognition from the scratch itself. So you have to create a data set by yourself. You need to put like 2 or 3 objects. So for each and every object you need to provide lot of data, like 10,000 for one class, like that, based on your accuracy which is required for you, and then based on the number of classes you need to provide lot of the data set for each and every classes. And then so like building out from the scratch. So that is the one way of creating the object recognition concept. And then there is another way which is by using a concept called pre-trained models. Like there are already a lot of pre-trained models out there, like for example MobileNet SSD, and then YOLO means you only look once. So these are all models are there. So with the help of that models, you can also apply, or you can also deploy a deep learning algorithm to recognize an object which is present in the frame. Okay, so that is the second way. And there is a third way which is known as a transfer learning concept. So with the help of transfer learning, you can able to use the pre-trained model weights, but by removing the last layer of the neural network, and it will be replaced with your data set, which is for custom data set. Okay, so these kind of deep learning networks and deep learning and machine learning. So if you want to learn, please register for AI Masterclass. Okay, there each and every topics was taught clearly, like what is meant by deep learning, what are the libraries and how to do that, what is meant by like a pre-trained network, and what are like how to develop from its scratch, as well as image processing, as well as video processing, and object recognition, and image classification. A lot of concepts we have discussed on that course. So if you want, you just please register for AI Masterclass also. Okay, so here we are going to use this second method, that is using a pre-trained model. Okay, so here we are going to use the MobileNet SSD. So here this is the architecture, that is like our neural network architecture of MobileNet SSD model, which has first of all input layer. So input layer size is up to like 300 cross 300 cross 3. 300 cross 300, that is nothing but a height and then width, and cross 3, which represent that is the channel. Like because here we are not going to use any grayscale or some kind of image. We are going to use a color image direct way. Okay, so for that, so that 3 represent the 3 channels, that is mean by RGB. Okay, so RGB channels. Okay, so and then we have convolutional layer, and then second first convolutional layer, and then each and every convolutional layer with the different dimensions, and then we have other layers like pooling and etc. Okay, so these are all it is the architecture of MobileNet SSD. Okay, so we'll go for the installation of library. So I hope you guys have already installed OpenCV with the help of OpenCV-Python. Okay, there are a lot of ways for installing a library. You can either install it from the scratch, or if you are installing using a pip, like for example sudo pip3 install OpenCV-Python. So definitely you may require additional libraries such as libhdf, f5. So these are all some kind of dependencies. So those also can be installed with the help of sudo pip3 install OpenCV-contrib-Python. Okay, so these are all like additional ways in which you can be able to use it for additional install a library, right? Okay, so you just please go for Raspberry Pi window. Okay, so and then go for the terminal. Okay, so on the terminal you just directly type sudo, so super user do sudo pip space install space OpenCV hyphen. Okay, so if you're doing that, so that library which contains the OpenCV, which will be installed in your Raspberry Pi. So since I have already installed, it shows the requirement already satisfied. Okay, so likewise you just do one thing, you just copy each and every line and you just paste it there, so that the dependencies will be installed in your Raspberry Pi. Okay, so here we have the source code. So here this is the main.py. Okay, so which contains the source code. So here what we are going to do, so once this code is ran successfully, then so it will, first of all, it will open the camera, and it will try to recognize, or it will try to identify which are all the object which is present in your camera feed. So and after doing that, so it will try to identify after identifying, it will start converting that text into a voice. Okay, so like a person detected, a mobile detected, and a vehicle detected, so like that. Okay, so for that, first of all, we'll explore the code. So before exploring the code, this is the main.py, this is the main code. Other than that, here we have two files, that is MobileNet SSD deploy.prototext file and then cafe model file. And while talking about deep learning or artificial intelligence, so there are a lot of frameworks for doing these kind of training. So for example, you can use Keras with the TensorFlow, or you can go for Cafe or PyTorch and etc. So here this model is pre-trained, that MobileNet SSD pre-trained model, which is done with the help of the framework called the Cafe. Okay, so which contains the Cafe model file as well as the prototext file. Okay, so here we have the code. So before that, we should have these two files which will be present in our directory. Okay, so that we can able to load these files into our program. Okay, so here we have main.py. So first of all, we have imported a library called import numpy and then immutals. So numpy is for doing array or that kind of operation, and immutals for doing a resizing, and cp2 is for computer vision operation, and time is for giving some delay or something like that, and subprocess is for calling like text to voice. I think we have already did that in the previous session. So here it's time to load that two model file which are already present in our directory in the two variable called prototext and then model. Okay, so for the model variable we have loaded MobileNet SSD deploy.cafe model, and in the variable called the prototext we have loaded the prototext file. Okay, so that's it. And then const threshold, so which means, so here we are going to compare any possibilities there or not. So that kind of threshold which we are given to point to. Okay, so now it's time to define the classes. So what is mean by classes? So classes is nothing but what are all the possible results which we can able to obtain from the deep learning model. So here we have background, aeroplane, bicycle, bird, boat. So these are all the basic object which is done with the help of MobileNet SSD. Okay, so here we have dog or cat or person and those things. So these are all the objects which you can able to classify. So classes is nothing but, so like what are the objects you can able to classify with the help of the, which also contains the background also, because if there is a background, it should not show anything, right? So that kind of concept. So we are going to use the background, aeroplane and etc. So and then colors. So colors np.random uniform. So here why we are using this colors variable is because if you are going to display that graph or displaying that output window, so that for person it should draw the bounding box in a like red color supposed to be. So if it is another object, there is a bottle also there means, so it should draw the bottle color with a different color. Okay, it should not draw with the same color. So that kind of random color choosing. So for that option we have initialized a variable called colors, and then so here we are going to deploy that cafe model which is already loaded in our directory with the help of DNN. DNN means deep neural network. Okay, which is already present inside that computer vision. Okay, so that can be done with the help of OpenCV-contrib that library installation. Okay, so net is equal to cp2.dnn.readNetFrameCafe of prototext model. So which going to load that prototext file and then model file into the certain variable called net. So with the help of cv2.dnn.readNet from cafe. Okay. So after that, now that net variable going to hold the pre-trained model file. So it's time to go for the main program, that is while true. So on that while true, and these parts, no. So this part is for like cv2.video capture of 0, which is used for opening the camera, and time.sleep of 2, which is 2 seconds. Okay, so while true. So while true of frame is equal to vs.read. So vs is already initialized as cv2.video capture of 0. So we are going to read the frame from the camera. We're going to assign it to the variable called frame, and frame is equal to metals.resize of frame comma width is equal to 500. We are going to resize the frame which is already read from the camera, and then we have specified the frame like we are going to get the frame height and then width with the help of frame.shape of colon comma 2. So colon comma 2 is like, that is the second parameter. So h comma w, so it's going to return the two return variables or return output, that is height and then width of the frame which we have already obtained. And then I am resize cv2.resize. So here we are doing the resize like to 300 comma 300. Okay. So and then because here we are going to convert that image into a blob image, because this this pre-trained model which requires the input frame or input image should be in the blob image. So blob is equal to cv2.dnn.blob from image. So we are going to convert as a blob from an image. Okay, so image going to be converted into a blob kind of format image. So these are all the input parameter for the blob image, and in the artificial intelligence, in the artificial intelligence course, these things which is explained clearly, like we have shown the demo for blob even. Okay, so and then now what we are going to do, we are going to set that blob image as an input for the net. So net is nothing but which we have already loaded our pre-trained model like here. Okay, so net is equal net dot set input of blob. We have loaded the blob image, and detection is equal to net dot forward. So this line will start doing a classification part where it's going to return the detection. So detections parameters, in the sense it may return where the object is located, the first thing, that is the coordinates of the object, like to draw the rectangle or the bounding box around the object. Okay, so that may be the first parameter, that is the coordinates, and then it will return the name or the class or ID, class ID. So class ID which is going to hold like 0 or 1. So if the class ID is 1, then output is aeroplane. So then the object which is present in the frame is aeroplane maybe. And if the object if the class ID may be like 0, 1, 2, 3, 4, 5. 5 means that is the bottle. So like that it will return the class IDs and then the coordinates to draw the bounding box. Okay, so detection shape is equal to detections dot shape of 2. So here we are going to get the shape of that detection part, and on the detection part, because here this is a like kind of multi-class or multi-label classification, because in a single frame if there is a two objects, it will try to recognize. So for example, if there is a two objects, like one person is also there, one bottle is also there, means so it should show both objects at the same time. Okay, so we are going to get in here and to get the confidence by the coordinates of detections of 0, 0, I, 2. Okay, so from that we are going to get the confidence value. So we are going to get the compare the confidence value to 0.2, because so this confidence comparison, no? So this line will make sure whether the object is there or not. Okay, so if the object is there, then the confidence will be definitely higher, like 0.8, or based on the accuracy which is classified. Okay, so based on the accuracy, if the accuracy is high or if the confidence level is greater than the threshold, then it will go in to get the IDX. That is mean by like it's going to get the coordinates. Okay, so IDX, and then IDX is equal to integer of detection 0, 0, I, 1. So this is nothing but detections array value where the IDX is located. Okay, so from that what we are going to do, this is kind of ID. Okay, so IDX is nothing but ID, class ID, which I have already told. 0 means background, 1 means the object which is there represented as aeroplane. So like that. Okay, so that is ID. So for ID is also which is obtained from the detections, and then box. So with the help of the box variable, we are going to get the coordinates like a width and then height of the certain square box. So for example, if the person is here and then mobile phone is here. Okay, so if it is supposed to be these two objects, then it will draw the bounding box that IDX is also a person. Okay, so points that is what is the person ID? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 16 it may be ID. Okay, so first of all it will take the 16th ID and it will also get height with like W and then H of my like complete body where it is located. Okay, so that is the box. Okay, so after drawing the box, so we are going to initialize that box as type as an integer, which has or which we are going to get the coordinates like start x, start y, and then index n y, which is nothing but a point. So if there is a point, so if it is a point, okay, single point, so it is nothing but it is going to hold on the two coordinates, one is x and then y. Okay, so if it is located here, that is nothing but start x and then start y. Okay, so and then that square box, the end coordinate, that is end x and then ny, which is going to be very helpful for drawing a rectangle. Okay, so around the coordinates. So and then label is equal to, so it's going to print out first of all name. So either it is a person or it may be like a bottle or something, and then confidence multiples of 100 to convert into a percentage. So it's going to print the confidence level, and it's time to draw the rectangle around the frame or around the object which is detected. CV2.rectangle of frame, comma start x, start y, there is the source, and index ny, this is the destination point, comma colors idx, this is the name, like it is the kind of like id, it is like id, okay, class id. So colors of id, in which color it should display. Okay, so and then 2, so 2 is nothing but a thickness of that line, border line which is going to draw. Okay, so this will draw the rectangle in a different color. And then if start y minus 15, so here what we are going to do, so here we have our square box, right, so which is drawn around me. So that is a person. So persons, that text should be returned like little bit away from that bounding box. Like if it is a person, means person, and then if it is the bottle means, so it will draw the rectangle around the bottle. On top of that rectangle it should print bottle. Okay, so that kind of thing we need that. So that's why we have assigned this coordinate to detect the y. And CV2.putText. So with the help of the putText, we are going to draw the or we are going to write the text around or above the like square boxes. Okay, so CV2.putText of frame, on that frame, comma label. So label is nothing but it's going to hold on the coordinates as well as the class name, comma the destination like start x, y, and then so these are the coordinate where it's going to print that text, and font, in which font it should type that messages. And then 0.5, so we are going to like set the coordinates, and colors idx, which is for to specify the color, and 2, which is for thickness of the letters. Okay, so this 0.5 is the nothing but a font size. Okay, so data is equal to str of class idx plus detected. So this is to convert that text into a voice, like a person is detected or mobile is detected or something like that. Okay, so here we have commented IM show of frame because like it may take a lot of time if you are displaying the image. Okay, and then key is equal to cv2.waitKey of 1. So until I'm closing that code, so it will display you the image or the camera feed. If you are terminated the program, that camera will be released as well as we will destroy the all windows. Okay, so I hope you just got this. Okay, so to know the or to show the frame, I have an idea. So I'm going to show the output in the Windows laptop so that you will understand what is the workflow or how it is going to display the output. Okay, so we'll connect the USB camera, other camera here. Okay, so let us remove the other parts to give the voice commands, because voice commands won't be worked then here. Okay, in the Windows run and the run module. Okay, if you are seeing here, the person is detected with a 99.99 accuracy. Okay, so likewise you can place any other objects which is presented in the class. So this person, so it will draw the one rectangle square around the object. Okay, whenever I'm moving, so it's also moving. The person is detected. Okay, so it is terminated. Okay, so that's the same code which we have did in there also. Okay, so in the Raspberry Pi. Okay, so only thing what we made a change is like we have commented the cv2.imshow function, as well as we have included lines which is used to convert that text into a speech. Okay, so let us unplug the camera and I'm just going to connect it with the Raspberry Pi. Okay, so that's it. We have connected here. Okay, so I have connected the speaker. I hope you guys know about this connection, right? The speaker and then Raspberry Pi as well as the USB camera. Now you are going to hear the sound whenever the person is detected. Okay, now it is giving person detected sound voice. Okay, just for a slow wave, just adjust the configurations. Okay. Okay, so I hope you hear the voice, right? It is it is just saying person detected. Okay, so likewise you can place any other object to detect whether like it is saying like vehicle, or you just show the chair, or you just show any toy car, so that it will detect the vehicle or something like that. Okay, still it is saying person detected because person is in front, person is sitting in front of the camera, right? So that's why it's just saying person detected. Okay, so like that, that's it, completed. Okay, so I hope you guys got this. So you can find this attachment code and the attachment file or additional file which is required to complete this project, that is MobileNet SSD cafe model and then prototype